Hello, welcome back. Ready for section 2 of chapter 4. I'm sorry, part 2 of section 1 of chapter 4. Now, in this section, I'm going to give you the graph, and you need to tell me what the domain, the range, and the zeros are, if you can. List the domain and range. Well, zeros, that's the easy part. Where does it cross the x-axis? So this first one, there's only one zero, and it's 1. Okay, easy part's done. Now the domain is how far to the left and the right does the function go. So get out your little beep beeper and we're going to beep beep. You ready? No beep, no beep, no beep. Beep 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 beep. And the beeping stops and then it just goes on. So where did it beep from? It beeped from x is about -5 all the way to x is 4. So that's the domain. It goes from -5 to 4, left to right. So we're going to say, okay, all x's such that it goes from -5, and there's an open circle here, so it doesn't include -5, all the way including 4. And it includes 4 because that's a closed circle. Alright, cool. Now let's do the range. Now we're going to go up and down. Okay? So get your arrow out. Start going up, 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 beep, 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 beep. And it stopped. Try that again. Beep, 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 and it stopped, and it goes up. So where did it start and stop beeping? It started beeping at -1, and it stopped beeping at 2. So your range goes from, it includes any y values from -1, and it includes -1 because this is horizontal. I needed to say that earlier, and I didn't. Otherwise, some kids might say, well, maybe it keeps going up and you don't know if it ever includes -1, but it does. -1 less than or equal to all your y values all the way to 2. There we go. That's the domain and range of that picture. Alright, here's an easy one. Okay, where are the zeros? Where does it cross the x-axis? Well, it doesn't. There are none. It never crosses the x-axis. Alright, domain. Here we go. Ready? Start on the arrow. Beep, 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 beep. When's it going to stop beeping? From left to right. It never is. So the domain, you can plug in any x you want. So x such that x is all real numbers. Alright, what about the range though? Okay? Range is up and down. So it starts up here. Go down this arrow. Beep, 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 beep. And it stops. Because it doesn't keep going down, does it? Beep, 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 beep. It keeps going up, but it stops going down. Stops going down. So the range, where does it stop? It stops at 0, 3, and the 3 is the value we're interested in for the range. So the range is all y values greater than or equal to 3. Does include 3. Okay, next one. This is a pretty easy one. Most people like this one. There's actually a dot there too. So the zeros, it's that first blue dot. It's at 0. That's where it crosses. And the domain, since all we have is 4 points, the domain will just include 4 x values. X could be 0, 2, 4, or 6. The range could be 0, could be 1, 2, or 3. Is that right? Yeah. So f of x can only equal 0, 1, 2, 3. That's a pretty easy one. Would you agree? Since it's not a continuous function, it's just a set of 4 points. There's only 4 elements to the domain and 4 elements to the range. It's a function though. So. Alright, and here's the meat and potatoes of this video. We're going to talk about piecewise functions. Piecewise functions are where you put 2 different pieces or 3 different pieces on the same graph. So I've color-coded this now, alright, and I need you to follow me here. Alright, this is important stuff. I've color-coded this. You're going to graph the green part of this piecewise function, which is a parabola, because x squared is just a parabola, but you're only going to graph it from -4 to 1. I've restricted your window from -4 to 1. Here's -4, here's 1. So what you're going to do here for that part, I would say make a table. Here's x, here's f of x. So let's make a table from negative 4 to 1. Negative 4, plug it in, 4 squared is 16. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And that's it. Stop right there. You have exhausted your window. Alright, so let's plot those points. Alright, 0, 0. Negative 1, 1. Negative 2, 4. Negative 3, 9. Negative 4, 16. It's going to be somewhere up here somewhere. And notice, guys, it says include negative 4, but exclude 1. You know what that means? The 1, 1, you need an open circle. So, and there you have it. Now, is that an entire parabola, or is that just a piece of a parabola? That's just a piece of a parabola, thus the term piecewise functions. Now let's graph the pink part. Now the pink part just says x plus 3. That really just means y equals x plus 3. Well, that just means that's just a line. And graph it from 1 to 3. So I would make another table, f of x, and plug in 1, 2, and 3. 1 plus 3 is 4, 2 plus 3 is 5, and 3 plus 3 is 6. Now it says include 1. So 1, 4, 2, 5, and 3, 6. But it says exclude the 3. That means that's 3, 6, you need an open circle. So there you have it. That's a piece of a line. Not the entire line. Just a piece of a line. That's a piece of the line y equals x plus 3. Alright, check out the zeros. What are they, friends? There is 1. It's right here. It's x equals 0. Okay, the domain. Tricky. Where does it start? Where does it stop? Remember, domain is left to right. What x values are included on the graph? Well, it looks like it starts at negative 4 at this point, and it stops at about 3 at this point. So that would be anything negative 4 less than or equal to x just less than 3. It's basically the combined combination of these two things, if you think about it. Don't include 3 because that was an open circle. And now the range, this is up and down. Okay, so all f of x's such that, where does it start? Well, go left to right now. Go up and down. So draw the line sideways. It starts here and it goes all the way up to here. How high did it get? Do you remember? I think it got up to 16. It started at 0. So 0 all the way f of x to 16. There it is. There's your range of a piecewise function. Congratulations, you've done your first piecewise function this year. These are always tricky for kids, but then once they get them, they're like, oh my gosh, why was I having trouble with that? That's super easy. This forces you to connect the algebra with the graph. Alright, last one I'm going to do in this video. Okay, we've got a green part. That's just a line. That's the line y equals, or f of x equals, x minus 3. But you're only supposed to graph it if x is smaller than 0. So if you think about it, if it helps you, make a little table. I'll do a green table. Start at 0. 0 minus 3 is negative 3. And now get smaller, right? Negative 4, negative 2. Plug that in, you get negative 5. So that should give you enough points to really get an idea what it looks like. But make sure you don't put an open circle because it just said less than, not less than or equal to. So open circle at negative 3, negative 1, negative 4, negative 2, negative 5, and the window never stops. So that's just a line that's going to go on forever. So put an arrow. Excuse me. Alright, this guy, he's a parabola. And he's from 0 to 5. So let's make another little table and only go from 0 to 5. Plug them into the pink parabola. Now, I've done this math for you already, so I'm not going to make you guys do it. It's negative 5, negative 8, negative 9, negative 8, negative 5, and 0. Plot those points. Watch out for open versus closed circles. It looks like every circle here is supposed to be closed. So 0, negative 5, right here. 1, negative 8. 2, negative 9, and then it bends back up. Oh, looking like a parabola. That's awesome. 4, negative 5, 5, 0, And check that out. There's the piece of the parabola that I wanted you to graph. And then finally, you're just supposed to graph 2. You're just supposed to graph y equals 2. Do you know what that looks like? It's a constant function. It's a horizontal line. So, and it says if x is bigger than 5. So if you plug in 5, you get 2. If you plug in 6, you get 2. If you plug in 7, you get 2. If you plug in 8, you get 2. If you plug in 100 and 1006, guess what? You get 2. So go up to 5, put an open circle, and draw a horizontal line. Boom, and it never stops. So put an arrow at the end. And there you go, friends. You have just graphed a piecewise function with 3 pieces. So let's talk about the zeros, domain, and range. Okay, zeros, looks like there's only one of them. It's right there. X could be 3. Domain, left to right. This function never stops going left. See this arrow? This green arrow? It's going to keep going left, and this blue arrow is going to keep going right. And there's no discontinuities in between, which means the domain, I love it when it's this because it's easy, is all real numbers. Now the range, however, let's see here. It's kind of tricky. This arrow never stops going down. It goes up, 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 up. It includes all these y values. And then this pink keeps going up, up, but then it stops. And there's a gap in the y values. There's a gap in the y values. And then there's only one y value on this blue line. See this table? What's that y value? That's just 2. So we have to account for that gap when we write our range. Here it is. All f of x's such that f of x is smaller than or equal to, what's the value of y right here? 0. And you got to catch the blue line. What is f of x allowed to be? It has to be everything smaller than 0, except on the blue line, it can be 2. And there you go. That's your range. Those are your y values. The y values included in the graph are anything 0 and smaller, and 2. And that's it, folks, for domain and range with piecewise functions. Tough stuff. Need some legitimate effort here. If you need help, let me know. I will catch you all later. Have a fantastic night. Make sure you dream some good dreams about your pre-calculus homework. And I will talk to you later. I'm out.